Oh, whoa, whoa, what's this? Oh, it's episode 3 of how to make a Dandylike in Godot. Wow. Hi, it's me. Fucking. Anyways, there were some bugs in the last episode, so let's go through and fix those. First issue that was available, you can pick up an item multiple times. So what we want to do is go to player, and we want to add a check here. So we want to go and not inventory dot has area. So what's that good? What that's gonna do? So let's head over here. Boom, it's fixed. So basically what we're doing is we're just checking if the inventory has the item inside of it already. It's pretty easy bug fix. Yeah. All right. Then also there's an issue with uncapped stamina. So that's also a pretty easy fix. What we're just going to do is like just right here, stamina equals clamp stamina 0 max max stamina. All that does is make it so that the stamina can't go below 0 and can't go above max stamina. So yeah, those are our 2 bug fixes. Now let's get into the challenge of last episode, adding more than one item type. So yeah. Now we have our item here, and we have our script here. So our code here is just for a single stamina item. And we want more items than that, obviously. So what we're going to do is we're going to remove this code right here, just make it return true. Then we're going to go to objects, go to item, and see this here? Right click, new inherited scene. Then we save that, go to objects, core mechanics, items, and then let's do stamina item. There. Now we have our stamina item as a separate scene. Then we right click up here, click extend script, and then let's name it stamina item.gd. There. So now we have a separate script that extends the original item script. So if we do func_use, that'll just override this. So then we just player.stamina plus equals 50 play q free return true. So then when we go back to the floor, we see our item here, and let's load. We want to load our stamina wait, where? Huh? Okay, it isn't showing up for some reason. Hold on. Let me just like... I don't know what... Okay, now it showed up. That was weird. So now when we go in here, you can see it's basically the exact same thing, except now it's more modular. So now we can make any item we want to. So let's make a new inherited scene. Let's make a placeholder extraction item, since we don't have extracting yet. So then we can go into floor. We make this an array, and we load. Boom. So now it'll spawn random items. So if we go into here, we'll be able to see that some items don't give back stamina. Yep. Obviously, I'll give those a use later in the video because we're working on tasks later in the video. But that's not what we're doing right now. What we're doing right now is making enemies. Yeah, enemies, the thing that kills you. Woo. Let's start by going over to our floor. So, in our floor, we're going to want to make a navigation region 3D. Now this, see over here, we're going to click here, make a navigation mesh. So under the navigation mesh, we move this and move it under there. Then we bake it, and boom, there is our navigation mesh. This will allow our enemies to actually move along the navigation mesh. Yeah. Now let's actually make the enemies themselves. Enemies. Let's create chaser. Make them a character body 3D. And okay. Here's our chaser. So let's just plop them down into the scene. Like just keep them there as a test. Why not? Now we want to add a collision shape 3D, just like we did with the player. Wait, we did that right? No, we didn't. And a mesh instance with a bean. And now we have our basic looking enemy. We're also going to want a second mesh instance to actually make them so we can make sure they're actually like facing where they're to make sure they're actually facing the way that they're trying to move. So now let's right click up here, attach script, and name it chaser. So now we have all the stuff that we started with in our player. We're obviously going to want to remove all of this stuff. We want we'll keep the gravity. We aren't really going to need any of that. So they actually need one more thing. Navigation agent 3D. That will allow them to actually navigate. Let's head into actually making them able to navigate. Start by doing an export var agent navigation agent 3D. So then agent dot get next path position, and for now we're just going to make them always chase after the player. So we just do var player var target player, so func underscore ready. So target equals get tree dot get first known in group player. That will just let us get the player from anywhere in the scene. Agent dot target position equals target dot global position. So then we also want to take some of our code from the player so they can do some acceleration. Var position vector 3 equals agent dot get next path position. No, we're going to want to name it pose. Var dir vector 3 equals vector 3 pose dot x minus global position dot x 0 pose dot z minus global position dot z dot normalized. And then we want to make them move dir. And var excel equals 100, var speed equals 100. speed equals 6, excel equals 6. Now we do dirt times speed times x times delta. So now when we run the game, they should move towards the player unless I got the math wrong. Oh, there we go. Yep. There we go. Oh, they're very slippery. I'm going to want to turn their excel up. But yeah, here's our chaser. But obviously I should make it so that you cannot walk them. So like, let's increase their speed to like 8. Let's also rename that to run speed since we're going to want to walk speed too. So now if we go in here, woo, they are they're colliding with our player a lot. So let's first of all decrease their run speed a bit so that they aren't catching up to us that quickly. So you notice that they're rubbing up against our player a lot. let's fix that by making it so that they can't collide with each other. So in here we just turn, so right here, character body, just turn the layer to none. And then right here, we also turn the layer to none. Now they will go through each other, and you won't be able to collide with. Oh, yeah, that is a bug. We're gonna want our player to actually be on layer 2, and then we're gonna go over to the elevator and make it so that the thing that actually checks for the two things that actually check for the player, they check on their mask is layer 2, so that they actually check layer 2. There we go. So now you can actually exit the elevator while being on layer 2, and the enemy won't collide with you. Let's give our enemy a line of sight. We're going to want to start with a shape cast 3D, and then let's go here. We want to create a convex polygon shape. This will allow us to make a custom polygon out of just points that we want. So let's just build our little polygon. Start with that. Go and over there. Just put it at 20x 40z. Then we just want to do same thing here. All right, cool. And then we want to add depth to it, so we just and then we add all right, there is our epic little line of sight thingy. Then we also want a ray cast under it, which we will use to actually check if the player is like between, if there's a wall between us and the player. So now let's go in here. We're going to want to we're going to first of all set make sure that we're going to remove that so that the player isn't always set. And then we're also going to want to do if target, then we do that. Else, we just set that to our current global position. So then they won't be able to chase us though, so we need to make sure they can actually like chase us. So let's make an export variable at export var line of sight shape cast 3D. Then we want to go assign that. Then if line of sight dot is colliding for result in line of sight dot collision result. We also want to make the collision mask number 2 so that they can actually see the player. So then let's check if result dot collider is player, then let's do target equals result dot collider. So now let's turn on visible collision shapes so we can see their line of sight. When we head over here, let's see. Yep, they instantly start chasing us. But you can see their line of sight is not rotating with them, so let's make them do that. So if target, then we're going to want to go var angle equals vector2 global position dot x global position dot y dot angle to point target dot global position. Then we want to rotation dot y equals angle. Oh, we also want to make this into a vector 2. Also, we want to do the z instead here. So now they should point towards us when they're chasing. Oh, they're off by 90 degrees. Oh, I forgot to do classic rad to de. I forgot to do the classic deg to rad. I love radians. I love radians. I love radians. I love radians. So yep, now they face you. So I just had to add this little bit of code. Feel free to just like copy this down. Yeah, because I don't know why exactly it's offset. It's probably because of the way we like rotated the it's probably because of the way we rotated this guy in here. But this works. So now they face you. Now let's make it so that they can actually like not chase you. So to do that, we're going to first of all go in here and add a little looping spot so that we can actually like probably escape them. One thing you have to keep in mind, whenever you change the map, you got to go back to the navigation region and rebake it. There's no way to automatically do it as far as I know. So now when we go back in, all right, cool, we can loop now. So I also turned on the visible path by just going right here. So now let's make it so that they actually lose attention. First of all, let's make an export. So at export var raycast var wallcast raycast 3D. Let's then define that. Boom, boom. So then wallcast dot target position equals to local target dot global position. So then if wallcast dot is colliding, then we're gonna want to decrease their attention span. So let's actually define that. Var attention float equals 0. Then down here, when we actually find them, let's set attention equals 3. So then if wallcast is colliding, then we're gonna want to do attention plus minus equals delta. If attention is smaller than or equal to 0, then we will target equals null. Else, attention plus equals delta, attention equals clamp, attention 0, 3. We're just gonna have 3 be our max attention for now. So then we can just like walk on over here. Let me grab these items for some stamina. None of them gave stamina. That's annoying. So then Oh, it's because right here. So we're also going to want to check, so let's make this a function. Func can see point vector 3 bool. Then we're going to do that. Let's pass in point. And we're also going to want to do wallcast.force raycast update, which will force it to update. So we could call this multiple times in a frame. So then right here, and then can see point, results.collider.global underscore position. And then up here, we're just going to do can see point. If not can see point, we're also going to, I realize we're doing this wrong, so we have to do not wallcast is colliding. Because if it is colliding, then we can't see the point. So then, that should work. Oh, what did I do wrong? Oh, I did gloval's position. Globular. So now you can see their attention is decreasing down there. And they stopped being able to see us, and they gave up. And you can notice when we step in their line of sight and we're behind a wall, they won't see us either. But if we are in their line of sight, they can't see us. Oh, and we can kill ourselves. Damn. Let's make it so that they can roam around the map. So let's go in here. Levels, floors, spawn nodes. Make a wicked POI, point of interest. That's what I like to call them. Then we just give them a, let's just make a quick drawing for that. A sprite, new. Okay, cool. We drag and drop that into there. It is twice as large, and I don't care enough to fix that. Actually, I do. I lied. I'm going to fix that. 0.5. Cool. So now when we go over to here, floor template, let's make a new node, a node 3D. Let's name it. I just realized I'm calling them wicked POIs. I'm just gonna call them enemy POIs because that's a lot better. And I'm very used to OCC if you couldn't tell. Enemy POI. Export var enemy POI positions. Then we make that node 3D. So then we just so then let's just do func underscore get random POI. Then we just have that return a vector 3. So then return enemy POI positions dot get children dot pick random dot global underscore position. That will let us get a random point of interest if we have the floor. So let's make them able to have the floor. So var floor, let's do floor, then func underscore ready. This means we also want to make a group for floors, so let's just go floor global. Then we're going to want to do floor equals get first get tree dot get first node in group floor. So then down here, let's do, if we aren't going for a target, we're going to go to the nearest point of interest. So it is target position equals floor dot get random POI. Then down here, let's also add a bunch of enemy POI into the actual enemy POI list node thing. I recommend not putting any of them near the elevator, otherwise that'd be evil and fucked up. Ooh, Looks like I forgot something. Oh, I forgot to actually assign that. Oops. Okay, cool. But you can see they're kind of having a bit of a seizure right now and kind of going to like the average point of them all. Let's make it so they actually have to like reach it first. So let's head over to Chaser. Let's do var current point of interest. Let's do a vector3. We want to then set current point of interest equals global position. So then if global position dot distance to current point of interest is smaller than or equal to 0.4, I'd say, then we retarget to the new position. All right, let's make sure that works. Let's just make this a function. Func underscore find POI. Then we just do this and boom. Then we just want to find POI and find POI. So now when we head over, oh, what did I do wrong? Yeah, let's assign the floor first. There we go. So now if we head over here, yeah, okay, so instead we're just going to do, because it seems setting that. Okay, yeah, that worked a lot better, but also, so let's make it so that they can retarget. So in here, in the else statement, we're going to want to do if agent.is navigation finished, then we do that. We're also going to want to go navigation agent 3D. Up here where it says target desired distance, up that to 2, and then that should work. Let's see. Now they walk around, but they don't actually look at where they're moving towards. So we're going to want to make a new function, func underscore rotate towards. Let's copy our code from earlier. Boom. Put it in rotate towards. Then we're going to want pose for our target position. So then let's do pose and pose. Rotate towards target dot global position. And then we also want to do that down here, except instead we rotate towards the agent dot target position. So now when we go in here, they will rotate towards wherever they're moving. So now we have our basic moving enemy. Can they spot us? Yep, they can. And then when we run around, ooh, yeah, they are very hard to, ooh, yeah. Okay, so now let's make it so that they actually like hurt us, you know, the thing that we kind of want to make them do. So let's first of all make it so that they actually have a little bit of pause time. So var pause time float equals 0. So then pause time minus equals delta. So then down here, we're going to want to set pause time equals 1 so that they have a little, they pause for a second whenever they finish navigating. So now they have a slight pause time, but now let's make it so that they can actually like hit the player. Let's make a shapecast 3D, make it a square, and just put it right there, I guess. We'll just use this box as basically their hitbox. And speaking of that, we might as well just move that in there. And then there we go. Okay, that's a bit more fair of a hitbox. So then let's do at export var hitbox equals shapecast 3D. So then when we're chasing the player for result in hitbox dot collision result, if result dot collision dot collider, is that how you spell it? Collider equals is player, then we will do underscore hurt result dot collider. We don't have a hurt function yet, so let's make that. Func underscore hurt player dot health minus equals 1. The player doesn't have that, so let's add health real quick. Health var health int equals 3. So then health minus equals 1, and then we also want to do pause time equals 3, since we want to give the player a bit of leniency so that they can actually get away. We also want to do target equals null. So then with all those factors combined, they're actually able to hurt us, right? Oh, what did it do? Oh, forgot to assign hitbox, of course. Let's rename some of these. Rename that to site. Name that to... There we go. So now when we go over here, go over queer, it's me, hi, I'm queer. They are not hurting us. Oh, that's why. We didn't give it a collision mask of 2. Yep, okay, that makes sense. So now if they touch us, they should actually hurt us. Oh, what did I do wrong? What? Oh, okay, I deleted wall. How did I? Okay. I accidentally deleted the wall cast. Oh, we got an error. Oh, we want to run this at the end because there's other things that we're doing that are like related to the target, and we're setting target to null. So, oh wait, we aren't actually like checking if pause time is bigger than 0. So, if target and pause time is smaller than or equal to 0. We want to change this to elif pause time is smaller than or equal to 0. And then we want to add our last else statement, which is just stopping movement. Then we also want to check here if pause time is smaller than or equal to 0. There. Now they'll stop moving once they hit us, and they'll start moving again after their pause timer goes down. Come on. And cool. We got hurt. And then they start moving again once their pause timer hits 0, right? What? Oh. Okay. Oh, wait, what? Why are they still targeting me? What? We also want to move this into here, because they are retargeting us. I'm Golden Freddy. I love to scare. And when I scare, I become a nightmare. You're in the office, probably gonna die. And you will die because you won't survive. Okay, yeah, there. So now if they hit us, and then they immediately will go back to looking for a point of interest. Nice. Woo. Yeah, we got our basic enemies. You can't die. I'll let you figure out how to make players actually die, because I personally just make them not able to die because it makes testing way easier. But that means we're on to our last actual mechanic of the series. Tasks. Woo, yeah, woo, yeah, woo. Let's start by making a counter for how many tasks are left. So var tasks left int equals 0. we're going to want to check here. And not floor is loaded. So if task left is smaller than or equal to 0, then floor is loaded equals true, equals false. So then in here, we also want to set tasks needed. Wait, no, we want to set task left equals, let's just do 4 for now. So tasks. I'm going to be showing you how to do 3 different tasks. Dandy's World styled, Depth Spelunking styled, and minus elevation styled. So because people have preferences, and some of them are definitely worse than others. Anyways, let's start by actually making the task object. Since there's so many tasks, I'm just going to make a parent class object and make multiple that inherit from it. Let's attach a script, name it task. Then we do class underscore name task. So we are going to want this thing to know, we're going to want this thing to have the floor inside of it. So var floor, and then we're also going to copy this code right here that gets us the floor. Ready, boom, there we go. Okay, so now let's set up our task a bit more. So var player doing, I couldn't think of a better name for that. So that's going to be just the player that's currently doing the task. And then we want var progress equals var progress float equals 0. So then up here, we want to do at export var locks player bool. That is what we're going to use to determine if this specific task should lock the player in place or not, just for some modularity. Now let's add a mesh instance right here. We're going to just make it like a sphere, and this will be the task. This is just the task, I guess. It's just an orb. And over here, we are going to make this, which will be the player's position in front of the task. I'm going to rename that player pose. And then we also want at export var player pose. We want a node 3D. We want to assign that. Okay, so now we also want to make player pose invisible because it's not gonna serve any gameplay function besides that. Okay, so then underscore physics process. So if player doing, so if we have a player doing it, then player doing dot global position equals player pose dot global position. Then we also want a bool completed bool equals true. Actually, no. Completed bool. Now we also want a function func underscore completed. Then we're going to do completed equals true, and then floor dot. Wait, we don't actually want floor. We want the main scene. But yeah. Let's give that a class name because we haven't yet. Let's also give it a group. Let's go to task. Let's make it do main and main. There we go. So then we got to do main dot task left minus equals 1. So now we have our task system basically. Let's also make it so that there's a area 3D on all of them so that the player can actually detect if they're like next to the task. Let's add a collision shape 3D and boom. Okay, cool. So now we want to head back over to the player. Let's actually place one of these basic tasks in main. Okay, so then let's go back to the player. So we're going to want to do something here. We're going to remove that. And up here, we're going to do var interact buffer bool. This is basically going to allow us to only interact with one thing at a time and not like if we accidentally pick up an item and like click a thing on the same frame. Yeah, we don't want to do that. So here we're going to do if interact buffer and area.get parent is task and area.get parent dot player doing equals null. And we also want to make sure it's not completed. Completed. There. So then let's remove all this code. Then var task equals area.get parent. Let's also make that a task. So, if player doing, I forgot something here, and locks player. And we also want player doing dot velocity equals vector3 dot 0. We just want to do that so the player doesn't get any gravity while dealing with the task. So then we want to do task dot player doing equals self. Let's also add a start function. So func underscore start. Let's also pass in player. So then player doing equals player. And then we're just going to do underscore start and then pass in self. So now we are able to actually start doing the task. So let's pop in. That's a very small hitbox. Oh, hey, it is actually like doing that. Let's actually make it so that we can see how many tasks we've done. So let's make a progress bar. Go to layout, position anchors, and then do top wide. And then we can actually like see our progress for the floor. Let's do $, floor progress, let's name it. Let's do floor progress dot value equals, oh, we don't have main. Let's make it so that we actually have main. Equals main dot task left. And I just realized we don't have a total amount of tasks, so var tasks total int equals 0. So let's do tasks total equals 4. So then we want to do value equals main the task left dot max value equals main dot tasks total. So now, yes, at 100%. Okay, so now that we did that, let's make a minus elevation style button, since that's the easiest one to make. Let's go tasks, make a new inherited scene, save that, and let's go over here, tasks. Let's name it button. Boom. So then let's head over to levels, floors, floor template. and we want to add 4 of these buttons. So let's go button. Let's also delete this chaser for now. Button, 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 button. Then let's head into button. Let's make an inherited script button. Then we just want to make it so that it instantly completes as soon as you press it. So we just do underscore start. We want to call underscore completed. Underscore completed. And incompleted, I just want to... Okay, yeah. Incompleted, we're also going to do player doing equals null. Just because why not? And we hit one of these buttons. Boom. 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 And we can't hit them multiple times, right? Right, game? I coded that right, right? Right? Yep. Okay. So now, let me just make sure that you can go through different floors now. So now, if I go in here, and that spawns me on a new floor. So now that's basically infinite, like, that's basically gameplay. We can play the game now. Wow. But you probably want a better task system than that. So let's make Dandy's World styled machines. My favorite game. Yay, I love Dandy's World. Oh my god, I want to kill myself. New inherited scene. Let's do machine. Then here, we're going to tick on locks player. And let's extend the script. Let's name it machine. Let's also give it let's also make this one like red. Let's do make unique. Let's give it a material. Let's make that material albedo. Make that red. There we go. Now we have a red sphere instead for a machine. So then in the floor template, let's just add the machine. So now if we go to machine, func underscore physics process, that's what we used before, right? Yeah. So then we want to do super delta so that it calls the previous stuff. So if player doing dot, then we want to do progress plus equals delta. If progress is bigger than or equal to, we'll just say 5 for it for now. So we're just on it for 5 seconds. Then we want to underscore completed. Let's also make it so that the player can actually get off of it. So let's go to task. Let's make a new function, func underscore leave. So that would be player doing equals null. So then in player, we want to do, let's make this a bit better looking. So if, I have to compare it. Elif area dot get. So then we just want to do then task dot player doing. So an elif task dot player doing equals self. Then we want to task dot underscore completed, not completed, fucking dot leave. So now you'll be able to get on and off the machine. Let's see. Let's go over to this machine. Let's we're extracting on it. We're extracting. Oh yeah, and it's done. So now if we go in here and then we click off, that lets us leave it. And it keeps the progress. And then let's also make a little indicator over it. So let's go sprite 3D. And then we also want a sub viewport underneath it. And then move that up here. And then in the sub viewport, let's go down here. And then in the sprite 3D, let's go here, viewport texture, make it be that. Ooh, that looks ugly. Let's just go 256 by 256, and then down here, let's turn on transparent BG. Then we want to add a progress bar. Let's just like layout, full rect. There we go. Then let's do $ progress bar dot value. Let's also do var time float equals 5. And then we do time there. Value equals progress. $progress bar dot max value equals time. So now you'll be able to see your progress on the machine. So let's go in here, boom, and then we can just fill all these machines. You can also hit the buttons still. Oh, I just realized we forgot to do something. Interact buffer. We want to consume the interact buffer. It's false. False. Okay, we forgot to do that because we need to do the thing that I explained earlier. And then let's do our last machine type. A puzzle type machine. Woo! Let's go task, new inherited scene, save it. Puzzle. Then we want to extend script, puzzle. And then let's design our puzzle real quick. Let's make it let's just make it like have a button pop up on screen, and then if you don't click, and then you have to click it. Click me, please. I beg of you. Let's make it invisible by default. Then let's also make this distinct from the other tasks. So make unique. And then material, standard material, albedo. Let's make it purple. Then when you click, then when you let's go signal pressed. So then if player doing, then underscore completed. Then also func underscore process. We want to do underscore physics process super delta. Then if, then we want to do $button dot visible equals player doing does not equal null. So now let's add some of those to the floor. Let's add a few of those to the floor template. Puzzle and puzzle. There. Oh, it doesn't unlock our mouse. I just realized. So let's just go input dot mouse mode equals mouse mode visible. And then when we complete it, we just player doing does not equal null. Then we want to make it visible, and then we capture it again once we click it. So then when we like go over here, click it. Why is it not doing that? You know what? Let's just change our interact key to E. There, that just makes things easier. Yeah, there. Now when we do that, we have to click it, and it works. Yeah, that was just because of some of the stuff we coded earlier. And now if we do that, then we can... Okay, but like, we don't want to place all these manually. We want them to be a bit randomized. So let's make a little randomizer thing. Let's start by making a spawn node for it. Let's name it task spawn. Instead of making it a sprite, we're just gonna make a mesh and just make it like a sphere there. Then let's make a node 3D. Task spawners. So now we have a bunch of task spawns. They're horribly laid out. Please do map design. When you actually make this, do map design. Think out your maps. Don't just make slop. Okay. At export var task spawn positions node 3D. So then in ready, let's do for I in main. Oh, we don't have main. Damn it, we need main here. Var main equals get tree dot get first known to group main dot task total +2. Why are we doing that? Because this is something that no Dandylike does for some reason. For some reason, they don't add extra tasks. This helps so much if you're like tasks that are in a static position. Because like, what if this task over here, for example, that's being camped by an enemy or something, or like it's in a bad position? Why would you not want to have extra tasks across the map that if that task is in a bad position, you can go those? You aren't required to do that one. There's 2 extras. So yeah, that's why I'm doing +2. So right here, we're going to do task positions equals task spawn positions dot get children. So then var new pose equals task positions dot get dot pick random. And we're also going to make that a node 3D. So var new task. We have to load in all the tasks. So I'm just going to make it so that every task type spawns. You can do this if you want. If you like all the task types, then why not just out of your game, I guess. I don't know. Fucking... That's probably bad game design, if I'm being honest. It was probably better just stick to a specific type. I don't know. Load tasks button. Load tasks machine. Load tasks puzzle. So then we will do task equals task types dot pick task types dot pick underscore random dot instantiate. So then add child new task dot global position equals new pose, and then new pose dot queue free, and then task positions dot erase new pose. So now wait, oh, I forgot to do dot global position. So now if we add in here, it errors. Why does it error? Because I forgot. Oh my god, I forgot to assign the export again. Yay, my favorite bug. So now if we look around, oh, there's some of our tasks. Now we basically have a game functioning. But there's one thing we're missing. One small little thing. One thing that we're missing. The enemies don't spawn. So let's do that. Let's duplicate task spawn, enemy spawn. Let's also just make it a mesh instance because I'm too lazy to make a sprite right now. Just make it a capsule mesh. So now in here, let's go back to our floor template. Those other tabs. Node 3D. rename it to wicked spawn positions. So then let's just drag and drop our enemy spawn. I keep calling them wickeds. Fucking, that's the OCC terminology. Let's make one over there, make one over there, make one over there. And then we're basically just going to do the same thing. So var enemy packed scene equals load. Enemies slash chaser. Wait, what? We're basically just going to do... We're just going to spawn one enemy for now. So var new enemy equals enemy dot instantiate add child new enemy. So then enemy dot global. I forgot to set it to an enemy. What? Oh. Forgot to do that. Yeah, global position equals task. Okay. Okay, I forgot to do export var wicked spawn positions node 3D dot wicked spawn positions dot get children dot pick random dot global position. So then we also want to assign that because I forgot to assign it last time. So now if you're heading into the game, we basically have a fully working game. Unless this guy randomly decided to stop chasing us. What? Hello? Chase me. Damn it, chase me. There we go. Okay, cool. We basically have a fully functioning game. Yeah. We have a fully functioning Dandylike now. Also, I forgot to make... Okay, we're just gonna make all these invisible because why not? And there we go. There is everything I can teach you, except for multiplayer, which is next episode. I'm not getting into that right now. That is going to be a shithole. So, time for your challenge. Your challenge is to figure out how to do multiple different kinds of enemies with different kinds of AI. Yeah, you probably already know how to do that since I showed you how to make multiple item types, but woo, figure it out. Woo.